So we have completed one where you have seen different techniques to solve network or circuit. Okay. There are some portions, uh, although it is not in the in your syllabus, that is AC part. So AC part, I will give you some material related to that, and you can cover or you can recap those things. Okay, actually, you have studied in your 12th that AC, what is AC, what are the power, what is power in AC, how we can calculate power in AC, these things you can. Vaishnavi, so how we can cover, how we can calculate power in AC, and what is AC, what are the RMS root mean square value, what is average value, all those things I think you have already studied. Okay, so I will provide you some document related to that, some material, and you can complete those things, you can revise those things.
Good morning, sir. Sir, actually, I wanted to say something. Sir, the lectures of the lectures are not uploaded after 27th of this
Yeah, I
August.
know, I know, I will upload today. Okay.
ओके सर एंड सर वन मोर थिंग सर मेरे यहाँ पर मैंने कभी भी गूगल क्लासरूम कभी यूज़ नहीं किया है तो मुझे ये चीज़ पता नहीं थी कि वो जो मतलब कॉपी करने के बाद अपना असाइनमेंट टर्न एंड क्लिक करना होता है तो मैंने अभी तक के किसी भी असाइनमेंट में टर्न एंड क्लिक किया नहीं था पर कॉपी कर दिया था मतलब 12 बजे से पहले ही कर दिया था एक दिन पहले हर असाइनमेंट तो वो टर्न इट लेट आ रहा है तो आप एक बार वो देख सकते हैं क्या थोड़ा सा कि मुझे पता नहीं थी ये चीज़ मैंने बाद में देखा कि वो मिसिंग आता है उसमें ऐसे रेड कलर का तो मैंने सबसे मतलब कंफर्म किया क्लासमेट्स से तो उन्होंने बोला कि टर्न एंड क्लिक करना होता है तो तब जाके सबमिट होता है वो
Are you able to watch this classroom, Google Classroom?
यस सर
So here is your class 2024-25 FEE, Fundamental Electronics Engineering.
यस
Okay. So if I go inside, you can see classwork.
यस सर
So I have assigned tutorial 3 also, and due date is September 16.
यस सर
Intentionally, I was kept this one because it was a bit late, but uh, you are coming here in offline mode on 13th, and
यस सर
15 is that orientation program. So you can submit it by Monday. Monday is also holiday here. September
ओके सर
is holiday. So you can complete, or it's better if you can complete before coming here. So you can also complete it before coming here. If
यस सर
questions are left, you can complete on September 16 also. Okay.
ओके
So suppose if you want to submit your assignment, so actually I can see here your work. So how many turned in? Turned in one, because September 16 is the last date is of assignment 2. Is a completed work I will see, that is, yeah, this one tutorial 2. So in tutorial 2, 34 students have turned in. Okay. So it means they have uploaded their, yeah, you can see here. Turn in means you have to upload your PDF file here. Okay.
ये सर ये बात पता नहीं थी मुझे मैंने कॉपी कर दिया था लेकिन टर्न इन क्लिक नहीं किया था तो अभी कर दिया है तो उसमें वो टर्न इन लेट दिखा रहा है तो आप प्लीज़ मेरा कंसिडर कर लेंगे
Some are here that they have already uploaded, but they have not turned in.
यस सर मैंने टर्न इन कर दिया था
Okay, okay.
बाद में
No issues, no issues. I will see.
ओके सर थैंक यू सर
So today we will start our next unit, that is about semiconductor devices. So before going to semiconductor devices, you know that there are some properties that of matter, that is conductor, insulator, and semiconductor. There are three types of uh, here you can see electrical properties of solids: conductor, insulator, and semiconductor. So have you studied these things?
Yes, sir.
Yes, sir.
So we will go briefly, and we will mostly means what is the difference between semiconductor and conductor, and means among semiconductor, conductor, and insulator. So after that we will more focus on the semiconductor devices. Okay. So as you can see, the conductors means they can be able to flow current in the element. So the conductor example is copper or aluminum. You can see that the electrical wires that are made up of copper and aluminum. Okay. Mostly overhead lines you can see aluminum due to the cheaper solution. Copper is mostly used in our household applications, where household wiring you can see copper is there, because copper has high conductivity as compared to aluminum. So that's why it has low losses. Okay, so that's why copper is used generally for electrical wires. Okay, so for making electrical wires. So as you can see here, the conductors have a cloud of free electrons, and due to the free electrons only, high current will flow. As much as the number of electrons will be there, the current will be means based on the number of electrons, charge will be there. Charge will be more as the number of electrons will increase. And you know that when charge will be more, current will be more. So that's why the conductors have high conductivity, and the current can flow through the material very easily. What is insulator? Insulator means they are bad conductor of electricity. Okay, so it means like for example polythene. So you know that in polythene there is no electricity flowing. So electrons are tightly bound to atoms, so few can break free to conduct electricity. It means there is no free electrons in insulator, so that's why almost nil the free electrons are there. That's why the current flowing capability is very low in insulators. However, if we can see the semiconductor material, for example, you can see the silicon and germanium. There are two main component of semiconductors. So although we are using silicon mostly, and there are several advantages of silicon device, silicon material. So as compared to germanium, so silicon and germanium, they are fourth group materials, as you know. So they have 4 valence electrons in their outer shell. Okay. So at very low temperature, they behave like insulator, means their properties will be almost matching like insulator. So at high temperature, when temperature increases, the more number of electrons will break the covalent bond, and they can free to move, and that's why it will behave like conductor when the temperature increases in the semiconductor material. So this silicon and germanium, these are pure semiconductor materials. Silicon and germanium both are pure semiconductor material. They are also called as intrinsic semiconductor material. So you know that the conductivity depends highly on temperature. Means for very low temperature, these semiconductor materials behave like an insulator. When temperature increases, they behave like a conductor. However, a poor conductor means they have conductivity is not so high. It is still a poor one. So the however, semiconductors have several properties that more make them distinct from the conductors and insulator. So the pure semiconductor material have not sufficient conductivity to flow sufficient current. Okay, so if we make device with pure semiconductor material, there is no use. So how we can increase the conductivity? How we can increase the conductivity of pure semiconductor material?
By doping?
By
Yes,
doping,
doping.
right? So pure semiconductor materials, you can see that uh, the thermal vibration results in some bonds being broken, generating free electrons which move about, and they leave behind holes. Means when electrons are moving from their place, they leave holes, and that's why there are two charge carriers, electrons and holes. So electrons are negatively charged carriers and holes are positively charged carriers. Okay. And at room temperature, these pure semiconductor materials have very few charge carriers, and that's why pure semiconductor are poor conductors, and they are called as intrinsic, and this is called as intrinsic conduction. And these materials, these semiconductor material are called as intrinsic semiconductor material. As you have already know, you have studied in your 11 12. So how we can increase the conductivity? To increase the conductivity, we will do doping. So doping means to add the impurity in the pure semiconductor. Okay, what are the impurity materials are there?
Trivalent and pentavalent elements.
Yes. So impurity means either we can add trivalent or pentavalent. So what is the reason why we are using only pentavalent or trivalent material? Because we know that in pure semiconductor, that means silicon and germanium, the outer shell has 4 electrons, and to make covalent bond, it needs minimum 4 electrons. Okay, so to make octet, they need 4 electrons, and if you want to increase the conductivity, so there must be the property of hole and electron in the doped material also, doped semiconductor material also. For that, it means 1 electron will be in the vacant mode and 1 electron will be in the access mode. So as per this property, there are two types of materials. Means either we can add trivalent, means they have 3 valence electrons in the outer shell. So 4 from silicon germanium and 3 from here, it will make 7. Means there is one vacancy. So it means there are excess of holes when we add trivalent. And for pentavalent, we know that in the outer shell 5 electrons will be there. So 4 will make octet with silicon germanium and 1 will be vacant. Okay, 1 will be free to move in the material. So one free electron will create excess electrons. Number of excess electrons will increase due to that. Okay, so they are called as n-type semiconductor material. So when we do doping in pure semiconductor material, the number of the conductivity of the material will increase, and to make the holes and electrons, means there are two there needs two properties of semiconductor type, means one should be in the vacant mode and one should be in the access mode. Okay, so vacant mode means the p type semiconductor material, access mode means n type semiconductor material. So we can add pentavalent material, and pentavalent are phosphorus, antimony, phosphorus, arsenic, antimony, bismuth. So these are pentavalent materials, and as there are 5 electrons in their valence band, so the 4 will make octet with the silicon on germanium, or germanium, and 1 will be in the excess. So 1 will free to move, and that's why the number of excess electrons will increase if we add pentavalent impurity in the pure semiconductor. And they produce n-type semiconductor material due to that. Okay, n-type is having number of free electrons, excess free electrons. And if we add trivalent materials, and trivalent are boron, aluminum, gallium, iridium. So these are trivalent material. So trivalent means they have 3 valence electrons. Okay, so 3 electrons will not make octet with the silicon germanium. So there will be 1 vacancy, means together 4 outer electrons from silicon germanium and 3 from boron, aluminum, gallium, iridium. So 4 and 3 will total be 7. So there will be 1 vacancy to make octet, and that's why the number of excess holes will be there. Means holes will create vacancy, and you know that holes have the positive ions, and they are called as a p-type semiconductor material. So if we add trivalent doping in pure semiconductor material, p-type semiconductor material will form. Okay. So both N and P type materials have much greater conductivity than pure semiconductor material. So to increase conductivity in the pure semiconductor material, generally we do doping. Okay, and they are called extrinsic semiconductor material, and this process is called extrinsic conduction, and materials are called extrinsic material. Extrinsic semiconductor. Okay. So these things already you know, just this is just a recap for everyone. Now we'll see in N-type materials, you know that the electrons are majority charge carriers. So in N-type material, electrons are majority charge carriers, whereas holes are minority charge carriers. Okay, so in dominant charge carriers in a doped semiconductor material, they are called majority charge carriers, means the more number of charge carriers are there, whether it is for electrons or holes. So based on the dopant, okay, there means the majority charge carriers will differ. Either it can be electrons or holes, and other charge carriers will be in the minority. Okay, suppose in N-type semiconductor material, we know that electrons are majority. electrons are majority charge carriers, and holes will be minority charge carriers. Similarly, in p-type, generally holes will be represented by H. So holes are majority charge carriers and electrons are minority charge carriers. Okay, so you can see here the p-type semiconductor crystal structure, n-type semiconductor. There are positive charges in p-type semiconductor because the mobile positive charges are here you can see in p-type because holes have positive polarity, and however they have negative ions. Okay, negative ions because of they are also called as acceptor ions. These negative ions are also called as acceptor ions. Or here in n-type they are called donor ions. Because they can be able to donate. Okay, so that's why they have positive ions in n-type semiconductor material. In p-type semiconductor material, negative ions are there. Negative ions and positive charges. So both will be there in p-type semiconductor material. In n-type semiconductor material, negative charges will be there and donor ions or positive ions will be there. And in the overall doped materials are electrically neutral. Okay, so overall doped materials are electrically neutral means there will be no electricity due to the only p-type semiconductor material and n-type semiconductor material. So next we will see the p-n junction. So how we can make the device? Alone p-type and n-type semiconductor materials are electrically neutral. So that's why if we make the junction, means if we close together these two materials, n-type and p-type. So when p and n-type materials are joined, this forms a p-n junction. And in p-n junction, the majority charge carriers on each side diffuse across the junction. We know that in suppose this is p, this is n, this is p, this is n. So in p-type, we know that negative ions are there. Sorry. In p-type, negative ions are there. And in n-type, positive ions are there. However, positive ions, positive charge carriers are there in p-type. These are holes. And negative charge carriers are there in n-type in majority. And in p-type, you know that together with majority charge carriers, means together with majority charge carriers holes, there will be some electrons also. So some electrons will also be there. We will denote by dot sign. Some electrons will also be there. Similarly, here in n-type, some minority charge carriers will also be there. Means some holes will be there. So what will happen if we joined these two semiconductor material P and N? So majority charge carriers in P type are holes. Minority charge carriers in N type are holes. So holes will diffuse from P to N. Holes will diffuse from P to N. What is the diffusion? What is diffusion? Do you know diffusion? Anyone?
When the particle move from the higher concentration to the lower concentration.
Right, right. Thank you. So holes will diffuse from P to N and electrons will diffuse from N to P. Because we know that in N-type semiconductor materials, electrons are in majority and in P-type, electrons are in minority. Okay. So electrons will move from N to P because here higher concentration of electrons is there. Here lower concentration of electron is there. Similarly here in P-type, higher concentration of hole is there. Here in N-type, lower concentration of hole is there. So electrons, holes will diffuse from P to N. Electrons will diffuse from N to P. Okay, and it will recombine. Okay, means holes from here, it will move to here. So it will recombine with the electrons. Similarly, electrons from here, it will recombine with the holes from here. Okay, so when they will recombine, these positive and negative ions will remove nearby this PN junction. So this is a junction. So nearby this junction, due to the recombination, what will happen? Some positive ions and negative ions will remove, and only immobile charge carriers, that is negative charge carriers here, positive charge carriers here, it will left. So the whole nearby this junction, there will be depletion region created. This is called depletion region. Due to the recombination of electrons and holes. Okay, so the ions will not be there. So I think it is there. Yeah, you can see here in the depletion region, only immobile charge carriers, that is negative charge carriers in P type, positive charge carriers in N type will left. So here there will be negative charge carriers. Here positive charge carriers. So only ions will left and they are immobile. They will not move. Okay, they will remain in their region. So in P type, the depletion region, negative ions will be there. In N type side, in the depletion region, positive ions will be there. So the width of this depletion region will depend based on the number of recombination. Okay, so majority charge carriers on each side diffuse across the junction where they combine with the charge carriers of the opposite polarity. means holes will combine with electrons, electrons will recombine with holes, and hence around the junction there are few free charge carriers, very few charge carriers, and we have a depletion layer. It is also called as a space charge region or a space charge region. So you can see here, due to the diffusion of positive charge carriers in one direction and negative charge carriers in the other, produces a charge imbalance. So here you can see that the depletion region is created. Here negative ions are there, here positive negative charge carriers, here positive charge carriers, and due to that they are immobile, they will not move, they will not cross the junction, and due to that you can see that there will be charge imbalance. Here negative charge ions are there, here positive charge is there. So if we plot here charge and distance, the characteristic, you can see that negative charge will be there, so it will be represented in the negative direction. Positive charge carriers will be represented in the positive direction. So there will be, that results in a potential barrier across the junction. So the potential barrier, you can see that the potential increases from negative to positive. So you can see that the potential, this is a potential barrier. This is called as a VB, barrier voltage. Barrier voltage. So this is a potential barrier, okay, in the PN junction. So next is, we will see what will happen, means how we can use these devices. Means we have studied PN junction without any bias. Do you know what is the meaning of biasing? Without any providing any supply, okay. So without any bias, we have studied that due to the diffusion only, the electrons and holes will cross the barrier, and due to the concentration difference in the other sides, the charge carriers will move and they will recombine with the opposite charge carriers. And when they will recombine, a depletion region will be created, and inside the depletion region only immobile charge carriers will be there. Means negative charge carriers in the P side, positive charge carriers in the N side. And due to that, charge imbalance will be there, you can see in the diagram, and this charge imbalance will create a potential barrier across the depletion region, okay, and this is denoted by VB, barrier voltage. Next we will see in the potential barrier how the current will means there are two types of current, diffusion current and drift current. So due to the flow of majority charge carriers, we know that the barrier opposes the flow of majority charge carriers, and only a small number have enough energy to cross it. Means although it will oppose the flow of majority charge carriers, some will cross due to the enough energy to cross that barrier. Means the energy must be greater than barrier voltage, okay, VB. So if any electron has energy greater than barrier voltage, so they will be able to cross the junction barrier, okay. So this generates a small diffusion current. So when in the potential barrier, if any majority charge carriers will be able to cross the barrier, so it will generate a diffusion current, okay. However, barrier encourages the flow of minority charge carriers, and minority charge carriers can cross the junction, and it generates a small drift current. So due to the flow of minority charge carriers, in the barrier there will be drift current, and due to flow of majority charge carriers there will be diffusion current. So this is also a very fancy question in Viva, also in interview also. What is the difference between diffusion current and drift current in PN junction? So diffusion current, there is a very much confusion between diffusion and drift current, that people generally think that diffusion current is due to minority charge carriers, drift current is due to majority charge carriers. However, it is opposite. Diffusion current is due to the majority charge carriers. Some majority charge carriers will be able to cross the barrier, and that's why due to their energy, enough energy, and there will be energy difference between the electrons which is crossing the barrier and the barrier voltage, and that's why there will be current flowing through that, and that current is called as diffusion current. However, the minority charge carriers can easily cross the barrier, and that's why due to the flow of minority charge carriers there will be drift current. Okay. So for an isolated junction, that is without bias, these two currents must balance each other and net current is zero. It means net current is zero in the PN junction without bias. Okay, means without bias, drift current ID must be equal to I diffusion. Okay, and the must balance each other, and the net current is zero. So the net current means I drift plus I diffusion, that must be equal to zero. Okay, that means the current flowing through the barrier. So when there will be no bias, means isolated junction, the net current flowing through the junction will be zero due to the balancing between drift and diffusion current. Next, we will see what is the meaning of bias. Either we can do forward bias or reverse bias. So do you know what is the meaning of bias? Have you studied the bias anywhere?
Sir, in probability, we
Yes.
read about that.
If you have studied PN junction in your 11th, 12th, PN junction diode, I think you have studied, right?
Yes,
Yes,
sir.
sir.
Yes, sir.
So have you studied forward bias and reverse bias?
Yes,
Yes.
sir.
Yes, sir. Yes, sir.
So if there is a PN junction, suppose this is P, this is N. So if we provide positive supply in P, negative supply to N terminal, okay? Positive supply to P terminal, negative supply to N terminal. So this is called as a forward bias. Previously, we have seen the PN junction without bias. This is P, this is N. Without bias. Biasing means to energize the circuit. Okay. Biasing means to provide the supply to the device. So if this is plus, this is minus. Without bias means there is no voltage between P and N. Okay. So there is no voltage between P and N. So the potential barrier will create due to only diffusion of the charge carriers. Okay, so in without bias we have already studied in the previous slide. Now we will, if we will providing forward bias, P will be provided positive supply, N will be provided negative supply. So this is called as a forward bias. Similarly, P can be provided negative, N can be provided positive, means we can reverse the biasing. So this is called as a reverse bias. And supply can be given through a battery. So suppose this is a battery voltage V, P is provided positive bias, N is provided negative bias, a negative supply. So this is called as a forward bias. In reverse bias, P is provided negative, N is provided positive. You know that in P type, holes are majority. In N type, electrons are majority. Okay, holes have positive charge, electrons have negative charge. Similarly here, holes are majority, that is positive charge, electrons are majority, negative charge. So if we provide forward bias, due to the positive polarity here, the holes that have positive charge carriers, positive ions, that will repelled by this positive polarity of voltage. Okay, so holes will be repelled by this potential, this voltage, and it will move towards the barrier. Okay, similarly electrons will be repelled. Here electrons in N-type material will be repelled by this negative polarity of the supply, and it will move towards the barrier. So electrons will move inside this side, holes will move this side, and they will reach nearby to the barrier. So means more number of holes and electrons will cross the barrier if we increase the supply. Okay, so if we increase the supply, more number of electrons and holes will holes from this side will be reaching to this side, electrons from this side will be reaching to the P side. So what will happen? Ultimately, depletion region, the width of depletion region will decrease due to this. So the width of depletion region will decrease. Okay, here what will happen in reverse bias? The width of depletion region will increase. Why it will increase? Because in reverse bias, P-type material is provided with negative supply, N-type material is provided with positive supply. You know that P has positive ions. So positive ions will be accepted by this negative polarity of supply, and that's why positive ions will be closer to this edge of this P-type material, and it will be far from this junction. Okay, it will be far from this junction, so it will move this side. Similarly, electrons, in electrons we know that negative ions will be accepted by this positive polarity, and they will be reaching far from this junction, and that's why the depletion region width will increase. So in forward bias, if p side is made positive with respect to the n side, the height of barrier is reduced, and the more majority charge carriers have sufficiently energy to cross it, and the diffusion current therefore increases while the drift current remains same. Diffusion current, we know that due to the crossing of majority charge carriers to the junction, and that's why more number of charge carriers can be able to cross the junction in forward bias, and that's why diffusion current will increase. Okay, and net current flow across the junction will increase with applied voltage. So when applied voltage increases, when the applied voltage increases, the more the current flow will also increase, okay, through the junction. So we will cover in the next class. There is time limit. I will take attendance. Ashish,
Present, sir.
Abhya,
Present, sir.
Aditya,
Present, sir.
Akash,
Present, sir.
Akhilesh, Akshit,
Present, sir.
Anand,
Present, sir.
Ankit,
Present, sir.
Apurva,
Present, sir.
Arnav,
Present, sir.
Avinash,
Present, sir.
Ayush,
Present, sir.
Gaurav,
Present, sir.
Kant, Krishna Gupta,
Present, sir.
Maitri,
Present, sir.
okay, Mudra, Paranjay,
Present, sir.
Prachi,
Present, sir.
Prajwal,
Present, sir.
Priyansh,
Yes, sir.
Priyanshu,
Present, sir.
Pulkit,
Present, sir.
Rahul, Rajiv, Rishabh,
Present, sir.
Rohan,
Present, sir.
Shrutik,
Present, sir.
Saket, Samyak, Sangram,
Present, sir.
Prasank,
Present, sir.
Shubham,
Present, sir.
Shubham Singh,
Present, sir.
Srajan,
Present, sir.
Sudhanshu, Sujit, Sumit, Supriya,
Present, sir.
Suryansh, Ujjwal,
Present, sir.
Utkarsh,
Present, sir.
Vaishnavi,
Present, sir.
Vedanshi,
Present, sir.
Vishal,
Present, sir.
Yash,
Present, sir.
Vinita,
Present, sir.
Sambhavi.
Present, sir.
Okay. Okay, then you can join your next class.
सर हम लोग को बुक्स कौन से फॉलो करना होगा इसके लिए?
बुक्स इसके लिए मैंने आपको बताया था, एक बुक है जो बॉलिस्टेड, पियर्सन पब्लिकेशन। ओके, ये बुक आपको लाइब्रेरी में भी मिल जाएगा, यहाँ जब आएंगे ऑफलाइन में तो आप लोगों को ऐसे मैं सॉफ्ट कॉपी भी प्रोवाइड कराऊंगा इसका, ठीक है।